All right, welcome back to chapter 1.1 video lecture. All right, so let's go through a question. Do movies that are comedies tend to get higher audience ratings than movies that are dramas? So say we want to answer this question, we have a data set with a bunch of information, and in that data set, in order to answer the question, what are the cases going to be? All right, so before I answer the question, the cases correspond with rows in a data set. So if you have a data set, you have to kind of imagine in your head a bunch of rows. What is each row going to be? You want each row to be a movie. So let's get a whole bunch of movies, and we want to know information about these movies. Okay, so same question. If we want to answer this, do comedies tend to get a higher audience rating than movies that are dramas? If we have the data set to answer this question, how many variables should there be? And when I say how many variables, what's the minimum number of variables? Think about what do we need to know? We need to know that is the movie a drama or a comedy? And we definitely need to know audience rating. So we need to know at least two variables. Is the movie a comedy or drama? And what is the audience rating for that movie? All right, same question. Do movies that are comedies tend to get higher audience ratings than movies that are dramas? In a data set to this question, how many of the variables are categorical? I'll go back. Is the movie a comedy or drama? And what's the audience rating? We're going to say one. We need to know whether the movie is a comedy or drama, and that's a categorical variable. And then same question, overall question, but then we want to know how many variables are quantitative. We can do 2 minus 1 to see that it has to be 1. Audience rating is going to be quantitative. Now there is a way to make audience rating categorical, like a thumb up or thumb down. But generally, if you think about Rotten Tomatoes or film scores or IMDb or whatnot, usually audience rating is, out of 100 or out of 10 or something like that. So it would be quantitative. Okay, so now we're looking at questions that have 1 or 2 variables. So maybe times we're interested in just one variable. As an example, like what is the average annual income for an SRJC graduate, say 10 years after they graduated from SRJC. So we have got a whole bunch of information about SRJC graduates 10 years later. But to answer this question, we would just need to know what's your annual income and take an average. I think a very common, especially when we're going into election cycles, for one variable, if you're working for a candidate who's running for Congress or governor or president, you just want to know what proportion of the people are going to vote for me. So that's just one variable as well. Other times we're interested in the relationship between two variables. And there's many examples, but does more studying lead to higher grades? Hopefully the answer is yes here, but we have 2 variables. How much studying are you doing? And, what are your grades? What's your GPA? How does sleep affect driving ability? You have to measure, well, how much does someone sleep? Maybe you dig deeper and think, well, how good does someone sleep? Maybe not just the length. And then how does someone drive? It's not an easy question. How do you measure driving ability? You could just look at tickets and accidents, length of driving, or you could do some type of driving test. But there are definitely 2 variables connecting. But actually, before we go on, really, it's going to be the last 2 to 3 weeks this semester, we're going to look at more than 2 variables. And there's a lot of questions and a lot of interesting things that involve more than 2 variables. We're just going to focus on 1 or 2 for most of this semester. Excuse me. Okay, so we are using one variable to help us understand or predict values of another variable. We call the former variable explanatory and the latter variable the response variable. So the explanatory variable, I think about this as explains the response variable. Let's do an example. Does meditation help reduce stress? Let's go back. So in this case, meditation would be explanatory, and stress level would be the response. And keep in mind, we're not trying to see for sure if meditation helps reduce stress, but that's how the question's posed. Does sugar consumption increase hyperactivity? All right, what would be the explanatory variable? Sugar consumption. We're trying to see, does sugar consumption explain hyperactivity, which would be the response? Okay, I'm going to go through a little bit more detail for each of these four scenarios. Which is the explanatory and which is the response variable. And for each of these variables, I'm going to state whether they are categorical or quantitative. Okay, so I'm going to write these down. Can eating a yogurt a day cause you to lose weight? So I'm going to say we've got explanatory, response, so explanatory variable here would be, write this down as eat a yogurt a day. Put parentheses here. The way we're writing this here is categorical, because this would be a yes or no question. And what's the response to this? It would be weight. Weight affected by whether you eat a yogurt a day or not. All right, an interesting study was done about 10 years ago, actually, but do males find females more attractive if they wear red? Let's see, while I'm typing, think about what is your answer going to be? So explanatory would be like, okay, you know, think about the explanatory versus response. And here it's the if they wear red. Does wearing red have any effect on the attractiveness? So explanatory is wearing red. Categorical. All right, we're going to talk about this on the first day of our in-class. Like, how do you define wearing red? What exactly is red? This is not a simple thing, but I'm just going to say wearing red. And we'll say here, attractive. Also be category. All right. Does louder music cause people to drink more beer? Explanatory. Response. Kind of went over this, but the explanatory variable is music. I'm going to write it as music volume in decibels. That would be quantitative. So trying to see right here, maybe you work for a bar or club or something like that. Okay, you want to get people to drink more beer, spend more money at your business. You're trying to see the music volume, does that affect or change the response in your beer consumption? Which would also be quantitative, as we talked about before. All right, last example. Do NFL teams that rush more win more games? All right, so we're looking at explanatory, rush more. So, as we done in football, instead of pass more. On offense, the team could rush or they could pass. So we're looking at, does the team rush more? Does more rushing lead to more winning? So maybe we could put like the number of rushes per game. That would definitely be quantitative. And what's the response? Does this have any effect on winning? Wins, let's say, per season. That would also be quantitative. Really quickly, I think there's an interesting, I put this question on here because about 10 years ago, a study came out on NFL that said teams that rush more do win more games. So the answer right here was a yes. But it's not what you think. So actually a number of NFL coaches then actually implemented rushing more than passing. It turns out winning leads to more rushing. Not rushing leads to more winning. So if you do follow football, I'll keep this quick. If you don't follow football, this is perfectly fine to ignore this. But it turns out a statistician then looked a little deeper into the study and found out that it was actually teams rushed more in the second half when they built a lead. So teams that are good, that win, that get a huge lead, then rush more because rushing kind of kills the clock. So it's the exact opposite of what a lot of coaches thought. You should win more that leads to more rushing, not the other way around, interestingly enough. Okay, so this finishes up chapter 1.1. Data is everywhere. It pertains to a wide variety of topics, which we'll look at for the rest of the semester, and hopefully the rest of your academic and professional careers and citizenship. Data sets usually comprised of variables that measured on cases. And don't forget, cases are rows, and variables are columns. Variables can be classified as either categorical or quantitative. As we talked about, they could actually be either or both, depending on the scenario. And data can be used to provide information about essentially anything we're interested in and we want to collect data. We're going to spend the rest of the semester talking about how do we use data in statistical analysis to answer these questions, and how confident are we on our answers. Okay, that concludes chapter 1.1.